Good evening, girls. We've inhabited or we've invaded your house with some circle geometry this evening, so that is something to look forward to. Doing a revision of grade 10 circle geometry, ready for our grade 11 portion. We have three categories of theorems. We have the center of the circle theorems in this column. We have the cyclic quad theorems, and in grade 11 we're going to learn the tangent theorems. There are three of each kind. So there are three center of the circle theorems, three cyclic quad theorems, and three tangent theorems. You can go through them systematically, and you need to listen carefully because at the end you would like to be able to write down a summary on your sheet of the reasons for each of the theorems and have a better understanding. The very first theorem we have is this one here. And there's two parts. The one part is the forward version, the other part is the backwards version. Remember, we call that a converse. Here we have a circle, a line from the center, perpendicular to a chord being a line cutting part of the circle off. And we notice that our theorem, the reason for our theorem, reflects what we saw initially. Line from center, perpendicular to chord. The result of this theorem, as we know from having proved it in grade 10, AM is equal to MB. Second part, second theorem, here's our circle, line from the center, bisect chord, and hence our reason, and the result is AB perpendicular to OM. We're going to go to our next theorem, which is on the next page, also center of the circle theorem. On the left-hand side here we have three theorems, like a triplet. They look similar, but not exactly the same, non-identical triplets. And the reason is the same for all of them. Angle at the center, because that's what we're reflecting what we saw initially. And what we have in each case is that this arc, AC, subtending angle OC at the center, which is double angle B at the circumference. Similarly, here's arc AC, subtending angle O at the center, and angle B at the circumference. This angled center is twice the angled circumference. The third picture is slightly different. And you will notice that we have this X outside angle, this reflex angle AOC equaling double B at the center. Our last theorem is to do with a diameter. The diameter subtends a 90 at the edge of the circle. Subtend means you are putting your fingers on A and B and you are making an angle C at the edge of the circle, and it's 90 degrees, and the reason is angle at the semicircle because that's what we saw initially. We are now moving back to the top four cyclic quad theorems, and the very first one we have is this one here. Recalling that a quad is a four-sided figure, we need to have that all four corners are on the edge of the circle to make it a cyclic quad, and we notice ABCD is just that. Angle B plus angle D, if you recall, are supplementary, and angle A plus angle C are supplementary as well. And our reason, given opposite angles of a cyclic quad. We don't need any more detail apart from that. You need to recall, though, that we have another theorem which sometimes is confused, and I want to just mention that at this point. Not to be confused with a parallelogram, where we have opposite angles are equal. And whereas in the cyclic quad, opposite angles are supplementary, as we said. Moving on to the next theorem, we have this theorem here. We have a cyclic quad, like in the previous picture, except we have an extension. And we get an exterior angle made when one of the sides is extended straight out. And so we have that EDC is exterior angle to this cyclic quad. And this exterior angle, EDC, is equal to the inside, hop over the line, across inside opposite angle. We've also met the terminology exterior angle in another place, so let's just make sure that we are clear on the difference between these theorems. And here we have a triangle with an exterior angle being made, and not to be confused with this, our exterior angle is x plus y. Exterior angle of a triangle equals the sum of the interior opposite angles. The last theorem that we have that we need to recap is this one. We again have a circle, four corners on the edge of the circle, and it looks like a butterfly because we've got the two wings. Of course, we don't call it a butterfly theorem. That is a colloquialism, an unacceptable reason for you to be used in a test or examination. Angles in the same segment, and the reason for that being is arc AD subtends this angle B at the edge of the circle and that angle C at the edge of the circle, and those two angles are equal. So angle B is equal to angle C and angle A is equal to angle D, angles in the same segment. Now we're inviting you to go through those 6 theorems again and to ensure that you have the reasons and the results firmly entrenched in your mind, so much so that you're able to fill in the summary sheet on your own and come to class ready to learn the last 3 theorems. Have a good evening.